Today we want to review the main ideas for Unit 3. We want to start by having you create a formula sheet. To make your formula sheet, what I'd like you to do is just take a blank piece of paper, fold it in half so you have 4 sections. 1, 2, 3, 4. We're going to put all of these formulas on our first section. So lay out your paper like this and start in the bottom left-hand corner with the first formula that we learned, velocity equals displacement over time. Next to that, you can put your 3 equations for accelerated motion. So constant speed, constant acceleration. I put all of these in red because these are all for linear types of motion. We then learned about our forces, and our 3 main forces that we worked with are gravity, universal, gravity on Earth, and force friction. We then saw that these 2 are connected together with Newton's law. So you can find your force, plug it into your force net, use your mass, get your acceleration, and put it into any of those 3 equations. Then we had our circular motion, so you get your acceleration, put it in here, and instead of delta x, we have delta theta r over t. Finally, we have 2 unique formulas for periodic motion, and they are the formulas for frequency and period. Remember, frequency is your number of cycles over time, and frequency and period are reciprocals of each other. So pause if you need to, but make sure you have a formula sheet with just these formulas on it. Put this in your reference section so you can access it throughout the rest of the year. Okay, unit number 3 is broken up into 2 main sections, projectiles and circular motion. With projectiles, here are the main ideas you want to remember. We have the idea of independence of components, which says you do your horizontal and your vertical as 2 separate problems linked together with time. We have the idea that at the highest point of our flight, the object will stop moving vertically. We saw that the best angle we can have if you're going from ground to ground is a 45-degree angle. Remember, when you're going from ground to ground, VI and VF will be the same numbers, just opposite, positive on the way up and negative on the way down. And if you start and end at the same height, your delta Y will be 0. Okay, just a reminder of your signs. We already created this chart, but just to review it, time will always be positive. The acceleration will always be negative. Your delta Y is based on where you start and where you end. So if you end higher, make sure you make your delta Y positive. If you end lower, make sure you have your delta Y negative. And if you end at the same height that you started, make your delta Y 0. Okay, the initial velocity will be 0 if you fire it horizontally. The V initial will be positive if you shoot it on an upward trajectory. So it leaves your foot or your hand or whatever on an upward angle at the beginning, make it positive. And if it leaves on a downward angle, make it negative. VF is positive if it was still heading up at the moment that we stopped looking at it as a projectile. VF is negative if it's heading on its way back down again at the end of our projectile flight. And VF is 0 if we are at the highest possible point, its highest natural height at the moment we stop viewing it as a projectile. All right, so I know we had this chart before, but it was over a month ago, so I just wanted to put it fresh in your head before the upcoming test. Okay, for projectiles, you also need to be able to take a triangle where you know the hypotenuse and the angle, find the y and find the x, so make sure you review that skill with your sines and cosines. You also want to make sure that if you know the two sides, that you can figure out the total, that is your hypotenuse, and make sure you can figure out your angle. So look back in your notes, make sure you remember how to do those skills, and if you need help, reach out to me and I will help you. Okay, we're not going to actually work through these problems, but I want to remind you how to do them. So here we had a drone that is traveling horizontally. It releases the projectile. Because it was traveling only horizontally at the beginning, you make this 0. If you're on Earth, you use negative 9.8. The projectile is going to go down, so you want to make sure you make your delta y negative. You want to solve for your time, move it over here. The speed it was moving horizontally goes in here, and you solve for delta x. Again, if you don't remember how to do this after I gave you that refresher, reach out to me. Okay, the next one we're going to look at Emily taking a shot, not this one, but this shot at the last second, a half-court shot. And we want to figure out the speed with which she threw the ball. Okay, so we bring it into video analysis. It left her hand at 1.8, it reached the basket at 3. You subtract them to get your delta. It's higher at the end, so your delta is going to be positive. We have the time that it left her hand, the time that it reached the basket, you subtract them, and you put them in for your time. Okay, use the distance from the half court to the basket. You can look that up on the internet. Just look at the dimensions of the basketball court. That'll go in as your delta x. So you'll know this. You'll know the time. You'll know this. You'll know this is negative 9.8. This was positive 1.2. And you want to solve for these two parts of your problem. And then you want to put them here and here to find the angle and the total speed. All right, so application of our triangles. Here's one where you're going to take the triangle. You're going to break it apart. If you can't read it, it's 19.97 on the hypotenuse and 53.8 as your angle. Work backwards, find the Vx and the Vy, put them in here and here. Because you come back to the same height, you'll come back to the same speed, only negative. Because you start and end on the ground, you're going to make that 0. You're going to make this negative 9.8. You're going to find your time, put it in here, and solve for delta x. So all things we've done before. Good luck. I hope you can work through it. Again, if you have problems, just reach out to me. Circular motion. Okay, you want to remember these terms. Angular displacement. Okay, this would be pi radians. Remember, every time you go once around the circle, that's 6.28, that's 2 pi. Angular speed. You take your angular displacement and you divide it by time. That'll give you radians per second. For your frequency, you do number of revolutions divided by time. That will come out in hertz. So you just count up how many times it goes around, you divide by how much time it took. Remember, period is the time for one cycle, and that is the reciprocal of frequency. To get the linear speed, we've been doing that a lot recently. You do the angular displacement, you multiply by the radius, and you divide by time. RPMs is how many times you go around in a minute. So if you take your frequency and multiply by 60, you'll get your RPMs. Okay, when you're talking circular motion, there's two big types of problems: satellite problems and turn problems. When you're on a turn, use friction. When you're doing a satellite, you'd use forced gravity. Okay, so if you were trying to figure out how long it took a planet to go around the sun, you start by finding the gravity. You take that gravity, you find your acceleration, you get your acceleration, you find your speed, and then you get your speed, and you solve for the time it takes to make an orbit. All right, so you don't actually have to work through them. We had just done some things just like this. Okay, remember if you have an altitude, you get the radius of your planet plus the altitude. Make sure you turn the altitude into meters before you add them together. Again, you shouldn't have to work through any of these. We've done them within the last week or so. And then finally, we just learned about cars going around a turn. So this is Route 55 South near Vineland. You could say it's not a perfect circle, but for the most part, the tightest part of this thing is pretty circular. And what you'd want to do is you'd want to get your radius. And just like we did the other day, you don't have to work through this, we just did it. Find your gravity, that's equal to normal. Find your friction. Okay, it says the roadway is dry and the car has new tires, so you can look them up on your yellow sheet. Use your force net over mass. Use your V squared over R, and you're solving for V. How fast can you go around that turn? Don't forget to cut your radius in half. I'm sorry, don't forget to cut your diameter in half to get your radius. Okay, anyway, they are all the skills and terms that you need to know for your test that's coming up.